so we're going to analyze, compare means, independent samples t-test, because these are two independent groups. And so the variable that we're testing in this question is BMI. And BMI, as I recall, you can actually make this bigger so you can see better. BMI is towards the bottom somewhere. Here it is, BMI. That's the variable that we're testing. And we're testing it as a function of sex. So sex is our grouping variable, so we'll push that in here. And this is where I was telling you, you have to know what the numbers are that you're trying to compare. So group 1 is going to have a value of 1. Group 2 is going to have a value of 2. If we'd used 0 and 1, then we would have just put 0 and 1 in here. So we hit continue, we hit paste. Now we go over to our syntax window, we highlight this command that we just pasted, and we hit run. And one thing that's nice about this is if it runs and it says you don't have these two levels, then you can go, oh yeah, I used 0 and 1, and you can just change it here. You don't have to go back through the menu. So you click run. Now this is our results for this t-test. You can see here's a log here too showing you. So that was the first t-test. Tells you it's one sample t-test. Here's our second t-test. Tells you it's an independent samples t-test. And it also gives you the group statistics. So you've got how many men and women you had, the mean for those groups, the standard deviation, etc. Now, the independent samples t-test, one of the first things that you have to do is you have to look at this test for equality of variances. And this is really important because if the variance is not the same, then you violated the homogeneity of variance assumption and you have to make an adjustment. Okay, we don't do this when we solve the problems by hand in class, but it is something that we want to do when we're using SPSS because of the power it gives us. So one thing that's confusing for students is that we actually hope that we would like to fail to reject this hypothesis. So the hypothesis for the test for equality of variance says that there is no difference in the variance between the two groups. That's the null hypothesis, right? And we would like to fail to reject that because we would like the two groups to have the same variance, to be homogeneous with respect to that. So we would like, in this case, for the significance to be bigger than 0.05 so that we can fail to reject. But what you can see here is that the significance value is actually quite large, right? Quite small, sorry, misspoke. Quite small, all right? So it's way below 0.05. So that means that the variance is not the same between the two groups. And you can get an idea of that, really, probably, if you look back up here. So this isn't variance, I recognize, it's standard deviation. But with these huge sample sizes, even though this doesn't look like a very big difference, that's a pretty large difference given the number of participants that we have. And clearly, it's large enough that we don't have equal variance. So what that means is that when you do the t-test for equality of means, you have to use the row of data that is when you are not assuming equal variance, because we tested it, the variance is not equal. So this is where it gets really important for you to show me what you're doing. So you're going to highlight this row so that I know that you're looking in the right row, because you can't assume equal variance. Okay? And when you look here, you'll see there's not much difference really in what you get. The significance is still the same, so it didn't matter if we made that adjustment or not. But what's changed is that you actually make an adjustment to degrees of freedom when you don't meet the assumption of homogeneity of variance. Okay? So we're going to then want to write that data into our results. All right, so let me find my page. All right, and what we're going to say is that, there is a statistically significant difference in BMI as a function of sex. There's lots of different ways you can say this, so you don't have to say it the way I wrote it. This is just one way to do it. Okay. Then after that, you're going to put your t, your degrees of freedom, which look funny, right? And that's part of how I know that you've made the adjustment for the failure to meet the homogeneity of variance assumption. All right. T with this odd number of degrees of freedom equals negative 3.89 or 90. We probably round that up, right? And p is less than 0.05. In fact, if you wanted to write it as p is less than 0.001, you certainly could, because that's also true. Okay, this is a two-tailed test, right? And that's what we need for that. Now we would also want to say results showed that BMI for the go back to our data. BMI for the women, again, it doesn't really matter how you write this. M equals 31.00, SD equals 16.53 was significantly higher than BMI for the men. M equals 29.48, SD equals 11.10. Okay, so let's go on to number 3 then. What test would you use to determine if there is a difference in BMI between people who have never married, all right, have never married, and people living with a partner? And the notes tell me that I'm looking at this variable called marital status, okay? And so I'm going to go have never married and people living with a partner. 2 different groups of people, right? They can't be both. They can't, well, I guess they could, but they've self-selected. That is a little confusing, isn't it? They could have never married and be living with a partner. But in this case, this wasn't my data set. In this case, these are different people. You can only choose one choice or the other. Okay, so we go back into our data file. We need to look at marital status so that we can find out what the labels were, all right? And I look here and I say, oh, there's a lot more than just 2, aren't there? And that's, again, why I need to know what the numbers are. So the question was asking me about people who are never married. That's one group. And people who are living with a partner. There's the other group. So I'm comparing people who answered 7 and people who answered 8. Okay? So again, now you guys should be with me now. I'm going to go to compare means, independent samples t-test. Am I doing body mass index? I am doing, yes, I'm still doing body mass index, okay? So I'm going to leave body mass index there, but now I'm going to change this, so I just shoot it back over there. I don't want it anymore. Now I'm going to find marital. Here's marital. Send that in there. I know that the groups that I want to compare are 7 and 8. Really important, because if you left that as 1 and 2, it would compare 2 different groups. People who are under 14 years of age and whatever, no, sorry, you can't quite see it, but anyway, it compared to 2 different groups that we're not interested in. So I'm going to hit paste. I'll be able to see, won't I, that I'm doing a t-test comparing marital levels 7 and 8. Answer 7 and 8. Run the analysis, and again, now you guys should be used to looking at this. So this top table just gives me descriptive data for the never married group and the living with a partner group. What I'm most interested in right now is the results of the independent samples t-test. We'll look at the equality of variance first, and now think about this. Okay, so last time it was 0.000. This time it's 0.436. My null hypothesis says there is no difference in the variance of the 2 groups. Okay? Because this significance level is greater than 0.05, I'm going to fail to reject that hypothesis, which means that I think the null hypothesis is true. There is no difference in variance between the 2 groups. And again, I could go back and I could look at the standard deviation here, and that might give me an inkling of why that is true or not true. And you can see the standard deviation is extremely close here. Okay? So once I know that this is greater than 0.05, that means that I get to assume homogeneity of variance, and so that means that I'm actually in this top line right here. Okay, so that's where I'm going to be. That's from where I'm going to be reporting my data for this analysis. Okay. So let's just go, so let's look at it, I'm sorry. So if we look at the significance, is there a significant difference in BMI between the 2 groups based upon marital status? And because this p-value is much greater than 0.05, that means that I'm again going to fail to reject the null hypothesis. So the null hypothesis said that there's no difference between the groups. This says that we're going to fail to reject the null hypothesis, so it says the null hypothesis is true. There is no significant difference between the groups. Okay, so let's go back to our Word document, and we're going to write out this result. Okay, there is no significant, you can put statistically significant, it doesn't matter, no, but you have to have one of those words, either significant or statistically significant. There's no significant difference in BMI between, and here's a different way I could do it. I could do between people who have never married. I could just write this right into my sentence so I don't have to use another sentence. The mean equals 29.50, standard deviation equals 13.70, and people who live with a partner. Mean equals 29.69, standard deviation equals 13.01. And then I put t with 14 1468 degrees of freedom equals negative 0.21. You see this, right? Here's the degrees of freedom. Here's the t-value, right? And p is greater than 0.05. It's much greater, right? It's 0.837. And this was, of course, run as a two-tailed test. Okay, so there's our answer to that one.